So we are being recorded. So anything you share or speak will now be recorded. So let's go ahead and start. Just arrange my screens here so I can manage what I'm presenting. Okay, my title screen should be up now. So welcome to software engineering. It's good to have you here online again, joining the meeting. Looks like we have a pretty good turnout, so let's go ahead and get started. So our devotion today is Matthew 11:28 through 30. Come to me, all who labor and are heavy laden, and I will give you rest. Take my yoke upon you and learn from me, for I am gentle and lowly in heart, and you will find rest for your souls. For my yoke is easy and my burden is light. I'm hoping this is encouraging to you. Does anyone have any comments, or does this resonate with you in any particular way that you'd like to share with the class? Okay, I'll take that as a no, and we'll go ahead and get started here with the lecture. So administrative items, the midterm in Canvas is due on Monday, April 6th at midnight. You can take it anytime from now or even earlier until Monday at midnight. So take it at your leisure. Please don't use any web resources, but I am making it open text, so you can actually refer to your textbooks or your notes. And the project individual work activity log is also due at midnight on Monday, April 6th. Take a look at that and please get that in. And then the design document, the SCD, I actually had it originally on Monday, but I've moved it back to Friday, April 10th. So any questions about those assignments or those due dates?
So if I understood correctly, we can use our notes for midterm.
For the midterm, yes, correct.
Oh, great, thank you.
And your textbook. But no Google searching on the web. All right,
okay.
So great. So we're gonna jump into the email design exercises that we've been going over this week, and then my goal is to jump into actually looking at some of the software requirement specifications. So if I remember right, and maybe I'm not remembering right, did we go through all of the software design UML diagrams, or were there students that we had not covered yet?
I think we were going to do yours next. I think we made it through just all the students.
Right. Okay. That's what I remembered as well. Good. Thank you. So bear with me. I'm showing my next one. So it should say UML diagrams review. Let me know if that is not what you're seeing. And
it is.
Okay. Oh, no, that's the review. Let's see. Now that I have it shared, it's the wrong set of slides. Sorry about that. Here we are. Okay, so now it should say UML design exercise. This was the problem. You'll remember the problem and got to work through the problem. This is just a simple use case diagram. An actor, he's interacting with both the elevator and the floor buttons, and these are the indications that the user sees of things happening, opening, closing of doors, the movement of the elevator, and button illuminations. So moving on to the class diagrams, this is what I came up with for the class diagrams. Note, I did an elevator controller, and which has 1 to n elevators. Another possible solution is you could have the building contain the elevators, but I went ahead with an elevator controller that is basically the controller for everything here. And we have a 1 to n relationship with elevators, or maybe, I can't remember if this requirement said something different, but I have 1 to n. It might have been only 2 elevators or a fixed number of elevators, but I have this 1 to n. We have the elevator control has a door that it's controlling on each elevator. And then we have 1 to m relationship with buttons. And then we have elevator buttons and floor buttons. We have that the elevator has the attributes of which direction it's moving, the current floor, and I misspelled floor there. And then we move, stop, and then we want the status of the elevator. We're going to be able to see what the elevator is actually doing. The elevator controller has IDs of the floor ID, the position that the elevator is in, and the direction up or down. The door is opened or closed, and so that's Boolean attribute or property. And then we can close or open the door. The buttons, it's illumination either on or off, illuminate or not. And then we have commands that's illuminate, cancel illumination, and the current status of the button. Again, that would be illuminate or not. And then we have the elevator button that has the floor number associated with the elevator button and the floor number for the floor button and the direction, whether it's an up or down button. So that is what I put down for the class diagram. Does anyone have any comments or see any weaknesses in this particular class diagram?
What was it, cardinality? I don't remember what the word is, but the 1 to
Yes.
n, was that supposed to be the 1 ellipsis in format versus 1 on each end? I mean, this format makes more sense, frankly.
Yes,
but...
yes. This is sort of the notation. The ellipsis would be the other technique, and you would have it based on, you know, where the starting point is and the end point. Yeah, I just think this notation, and you probably, well, I guess I could use M, but usually use N. I actually have M here for the button. It should probably be N. But yeah, I believe that most of them do have the ellipses, and they have it on one end or the other based on which one you're starting from. So that's a good observation. So there's a notational difference that I chose to use here. Any other questions or comments? So here I also am missing the cardinality between the elevator controller and the door. That would be a one-to-one relationship there.
So is this notation also valid, or are they just different options?
Yeah, I think strictly if you went to the UML specification, it may not be strictly valid, but it certainly conveys enough of what I'm trying to convey. So I don't think anyone would fault you on that, as long as you have the rectangles with the rectangular section at the top with the class name, the section below it with the attributes/properties, and then the box below it with the operations that can be performed on that class. I mean, those are the key things. Yeah, most people won't nitpick about the syntax, but yes, there is a difference here in the syntax, I believe, than the standard. And you could look at the standard yourself if you wanted to. It's all available online. So interesting. Good observation, Jason. Any other comments? Questions? Objections?
What is position an elevator controller? What is that supposed to be?
That is the current position of the elevator.
So what floor it's on currently?
Yes.
And then the floor ID is just the buttons that have been pushed in the elevator?
That's a good question. What was meant here? I believe the floor ID is the next floor that you're going to, and the position is where you're at. Was the intention. But yes, good point, Isaac. There is a clarity problem here, and it hasn't been fully fleshed out. So that is a good review question. It says, what do you mean by that, and how is that going to work, and will it work? It looks like I have a deficiency in my design here with the elevator controller, because you would probably expect also to see an array of floor requests, and then you could use that array of floor requests or list of floor requests then to work on your algorithm of deciding which floor to move to. So definitely, I would say it's accurate, Isaac, that there is a deficiency in the elevator controller attributes and its design, that it hasn't been fully fleshed out. So that's a great observation, Isaac. Thank you. Any others? Like I said, what I just threw up here was something I put together quickly, and there is no right or wrong answer, and definitely what I put up here is not necessarily right. So keep that in mind, and feel free to say, hey, I don't understand something, or something looks like it's off, because you're probably right. So please jump in. Okay, I happen to have done a sequence diagram for the elevator button. So we have the passenger pressing the button, and then it is communicating an update to the elevator controller, and the elevator controller sends back an illuminate message. We have cancel illumination going to the elevator after the elevator controller sends the move command to the elevator. The floor is reached, and then we've stopped, and the door is open. The cancel illumination will happen. And so you can see all the interactions and sequence of operations between the passenger, the elevator button, the elevator controller, the elevator, and the door. So this would be in lieu of a flow chart, because essentially it is a flow chart. As you go down, you can see the sequence of operations that happen for the UML sequence diagram as you progress down from top to bottom in the sequence diagram. So we can see here the opening and closing of the door, and the actual thing that would happen in the elevator controller would be a time delay, that it decides to close the door at the floor until the button is pressed if there aren't any other requests for movement. So this is a basic sequence diagram. Again, I have no qualms with a sequence diagram being replaced with a flow chart, but you will, even though if you choose to use a flow chart, you will need to be able to understand how to read a sequence diagram, because it is commonly used in industry for showing the interactions between various classes and the flow of control and of data. So any questions or comments or objections to this diagram?
So you're supposed to read it from top to bottom and then left to right?
Yeah, it's left to right is more. Yeah, it is kind of left to right. It's the flow across the classes, but certainly time is going from top to bottom. So that's how you'd read it. So it would be the passenger presses the elevator button, an update goes the elevator controller. We go down, and that says, okay, illuminate the button, and then going down, we move the elevator. The elevator controller tells the elevator to move. The elevator moves, and then eventually a floor is reached, and that signal sent to the controller. And yes, that's how you would read it. You do kind of go left to right as well, but time actually goes from top to bottom.
Okay. What about those little boxes on the elevator column where there are like 3 different boxes? Is that like specific?
That's just sort of indicates that time has progressing, that there's a time delay until and that there's something happening, which is basically the elevator is being told to move, and that it takes some time for the floor to be reached. But now I did do something weird with the boxes once the floor is reached, and the stop signal is sent to the elevator. That is not really purposeful, other than maybe you can consider the movement in the box that the floor reach command goes to, and that could be motion control. But yeah, there isn't anything specific with the little boxes. It's just trying to indicate passage of time and those kinds of things.
Okay.
And you can certainly look at, if you're interested in the actual specification again for UML sequence diagrams, and see if there's any other details. But it does notice how we have the boxes with the other ones as well. It's just sort of indication of things happening, kind of.
So does it progress down all of them at the same time, or does it like start with the passenger and then pass control to the elevator button once it's pressed?
It really does pass it on, but it does go down in time waiting for responses back. So in the passenger case, we don't really have anything showing there, which is probably a mistake. But we can see here that the elevator button sends out the update and then progresses down and then receives the illuminate. And then when the commands go to the elevator, move, floor reached, and stop, that we can see the elevator does progress down and is waiting for the cancel illumination or cancel illuminate event from the elevator controller. So I heard a comment also.
Yeah, it seems like this isn't so much describing passing control as in like a single threaded system. It's multiple systems that are passing messages between each other. So it seems like the horizontal plane is more just grouping together the different functions happening on the different components. So it would be read top to bottom. The horizontal is just grouping where things are happening. So more like
and that's a great, Jason, that's a great observation also, in that oftentimes in a real-time system, these will be events or messages passed, exactly like Jason said, or in a system that is not real-time or not distributed in that fashion, it could be just a method call. But yes, there is some type of message passing or event passing that's happening that could be either implemented through event handling system, if that's how you decide to implement it, or it could actually be a method call when you delve into implementation. But you're right. This can, a good way to describe it would be message passing or event signaling. So that is a good way to view the sequence diagram. How that goes into code can be multifaceted depending on how your architecture is designed and how your implementation is designed. Any other questions before I move away from this slide? Questions, comments, objections, all of those are welcome.
Yeah, so I guess the only other one, I recall it saying somewhere, I don't know if it was for UML or if it was for one of the architectures. I've been catching up on a lot of reading, so it's all mixing together.
Yeah.
That is it acceptable for the elevator controller to communicate directly with the door, or should that technically go through the elevator, which would then tell the door?
No, it's all the classes can, in general, communicate with all the other classes. So elevator controller directly to door is acceptable. But now that depends on your architecture as well. If you've decided that this is leveled and that there should be an intermediary, then yes. So that would be a high-level architecture decision. But in terms of the actual sequence diagram, there is no restriction on events crossing all the way. So, for instance, it is possible, and it probably doesn't make sense in this design or this particular problem, but it is possible for the passenger to send something directly to the door. There isn't any leveling per se that goes that says you have to go through all the intermediaries to get to the next class, other than your high-level architecture may designate that, but not the sequence diagram. The sequence diagram allows you, and so you can see here that we laid out the classes in a particular order that made most sense for the diagramming purposes, that it's in general moving left to right and one at a time. But like Jason pointed out, the elevator controller is communicating directly to the door and not going through the elevator. Now, your architecture could be that, yes, you are speaking to the elevator, and the elevator owns the door, and that you actually command the elevator to open and close the door, and then the elevator sends the message on the door. So that could be a architectural decision, but it isn't limited by the diagramming technique. It would be limited by your architecture decision.
Okay. And I see the passengers going through the elevator button to communicate with the controller as well. So that makes
Yes,
sense.
in this particular case, yes.
Okay. Only other thing I see is the door's never open to let the person in.
Oh, you mean to begin with? At the top?
Yep.
Yeah. It's only at the bottom after we stop, the door is open to let the passenger out. But yes, either the door has to be already open or you open the door, and certainly if we close it after a duration, which is shown in the elevator controller, then yes, you would have to have the press button, update the elevator, and you would have to open the door, close the door, and then start your movement. So yes, we're missing the open and close at the beginning. We have the open and close at the end, but when we get to the destination, but we don't have the open and close before we move, letting the passenger in. So that's again a good observation.
Wouldn't that open and close be the same? Because the elevator has to get to them, then open. They press another button and it starts all over again?
The door's always closed when you reach the elevator, though.
Or
so
it could
be. Yeah, I guess if someone is standing there right when the elevator arrives, then it would work fine.
Right.
It does depend on the elevator. I know that there are actually some places where on the floors that they'll just leave the elevator doors open. I've seen that before.
Yes.
Right.
So, and
but
that,
that's
again,
not the normal design, I don't think.
Well, and guess what? This is exactly the kind of discussion in a review like this that needs to come out is, what is the approach? Are we going to leave the door open, or are we going to leave it closed, or are we going to go ahead and close it after a specified period of time and then close it? So these are all things that come out in viewing a diagram like this in a review, like we're simulating now. So that's a good point, Gabe, is what is our convention? Do we delay and close the door once we get to the floor, or until we start getting ready to move to another floor, maybe we leave it open? That's certainly a valid choice that could be made. And then you have to discuss what are the pros and cons, and are there any issues with a particular design choice. So anyone else see anything that strikes them? Okay, so I didn't actually have you do a sequence diagram, but this is hopefully gives you kind of a feel of how you'd use a sequence diagram. And again, I'm of the opinion, even though it's not UML, flowcharts are easy to read as well. So here we go. We're looking at state diagrams now. So we see that I have a state diagram for the elevator button. So that's the button inside the elevator is what I'm referring to there. So we have my initial state for the button inside the elevator is that it's off. And then, and basically you can see the action that happens whenever you enter into the off state, then the light is turned off. So that's what I'm indicating there. The light off method happens when the elevator button reaches the off state, the light is turned off. When the button is pressed, it goes to the engage state, and we send an update command to request the floor, and that it would be I presume would be an event that goes to the controller based on what I recall my sequence diagram looked like. I guess we can go back and look at it. Yeah, so there's my update. You can see my update command after being pressed. It goes from the elevator button to the elevator controller, and that is exactly what is being represented here in the state diagram. Is that I'm doing the update command, requesting a floor. The next state is that it's illuminated. So it's time to go ahead and illuminate. We requested a floor, and the illuminate event comes in, and the light is actually turned on in the on state. So we've traversed. So we engage it, which is a method that's sole purpose strictly is to request the floor for the button that is the floor button itself. Then we illuminate, which is turning the light on. And then when the floor is reached, going back here, floor is reached, we do a stop, and then the elevator controller sends the elevator button a cancel illuminate event. And so here's the cancel illuminate event that takes us to the off state. So I actually invoked this extra stage that was engaged. You could probably argue, well, maybe you could actually incorporate the update request floor into the on button. But so that is another choice, that the update request floor could be encapsulated in the on state. I can't particularly remember why I came up with that extra state instead of the on, but does anyone have any questions or any comments about that particular choice or any other thing that they see?
Would you just remind me about the solid dot?
So the solid dot is basically the initial state for this class. So this elevator button class would initially start or be initialized at the off state. So that's sort of the starting state. In this case, we don't have an ending state, but there's also a circle, a solid dot with another circle around it, which is a termination state, which means that when you issue an event that would cause this class or instance of this class to go away, that it would then traverse from this event to the cancellation state, which is you no longer exist. The instantiation goes away.
Okay.
So the solid, again, the solid blue one is entry. Termination state would be the solid circle like I have there with another circle surrounding it. Okay. Oops, did I go? Or door? Yeah, elevator button, door button. So again, I use the same kind of model. The door button is pressed. It's update request floor, which is the current floor. The requested floor is the current floor, and then illuminate, and then lights on, and then cancel illuminate. So very similar. It's just the requested floor is hard coded to the number on the button in the elevator button, and then associate it with the floor on the other side. And the other thing is there probably should have been something else in the engage button. Can anyone point out what I missed here in the engage button? Well, I guess actually you kind of know. It's whether it's an up or down button. But I guess that would be a property that would be inherent to the door. The door button.
Yeah, I don't really know how I would do that.
Any ideas? So yeah, one of them I stated was, okay, you could just record as a property that when I initialize the class for the door button, I know what floor I am and what direction button I am. What other ways could this be done that someone might think of or think might be a better alternative? So a comment that Gabe could have made is, yeah, for some reason something doesn't quite feel right to me, but I don't have a solution necessarily. I will take it as an action item and to solicit other ideas and see if I can come up with another idea how this can be improved. And so as part of this review, we could have an action item saying, something doesn't quite sit right with me here, but I don't know what is wrong or what the answer is. But let's make this an action item. So that would be certainly a valid thing to do. Any other comments or questions regarding this state diagram?
Caden put something inside the chat. He said the request for is unique to each button as a question.
The request for is unique for each button. Yes. That's right. So that is a state of the door button or the floor button. I think I changed the name of it. I think I called it floor button somewhere else, and now I call it the door button. So that's another mistake. That this, in fact, a door button, I don't think was even one of the classes I laid out. But yes, it should be a floor button, I think. So yeah. It is a property that's unique to each floor button, so it may be hard-coded and not necessarily with the request floor. But this is a message going to the controller, so you're passing the request floor that I am associated with me to the controller. So this is a message that's going out. So that's why that is an argument. That is a method that the elevator controller would have, and it would be up to the button to send the appropriate request floor, either my unique request floor because I'm at this floor and probably up or down, or yeah. Actually, I guess it wouldn't be request floor, would there? It should be up or down. That's
you
what's
could
wrong here.
incorporate the direction into the floor request by just a positive number is up and down.
But yeah, this is something. Yeah, that's a good point. But I'm starting to see there's a mistake here because the elevator button certainly will have a request floor. It's what floor I'm going to go to. But here, oh, the request floor is what floor I'm on. Yes, I'm sorry. I was thinking, how would you know which floor you're going to? You don't know what floor you're going to, but you know what floor you're at, and you're asking the elevator to come to me. So yes, that is the request floor. So there, I just kind of walked through something that I thought looked wrong, but it realized why I had done it this way. Any other questions or comments? And Ian, was your comment or I think it was Ian that jumped in. Was your design question or comment addressed there? I might have stepped over your comment, Ian.
Well, I mean, I was just saying you could incorporate the direction using a negative or positive number. But if you're calling the elevator to you, it might not.
Right.
Right. No.
Yeah, it would be probably
Oh,
overloading the attribute for the rest floor. I know why I keep cutting over you. Your audio is cutting in and out, Ian. I don't know why, but is everyone else hearing what Ian's saying? I'm just hearing bits and pieces of what
It's
he's saying.
cutting for me as well.
Okay. Yeah, and so I hear a few words and then I think he's done because it cuts out and then he's not done. So you could also chat that question because your microphone is cutting in and out, Ian, if you want to chat that to me. But I think what he was saying is you could use a positive or negative number to the floor to say which direction it is. Oh, here's my new message. I assume that's from Ian. Oh, Wachir said nope. I'm not sure what that was in response to.
I was saying I can't hear.
Oh,
Ian
yeah, he
as
can't.
well.
Yeah, you can't hear him either. He's cutting in and out. Yeah, I see. So yeah, you could put a negative number depending on whether you're requesting up or down, but it might be better to actually, instead of having a negative number, put a request floor and then have another attribute that's up or down that's associated with this button. The actual elevator buttons inside the elevator wouldn't have that, but you would have a update method that would actually have the direction that you're requesting as well. Well, that might be another request, right? Because you're actually requesting that you come to my floor. Yeah, I guess you would say I'm requesting you come to my floor and I want to move up, or I request down, because you could skip a floor and go all the way down and then come back up if the elevator wanted to come up and the elevator is higher than where you're at now. So again, these are all design decisions that come out of a review like this of a UML diagram. And again, also keep in mind that UML diagrams are very illustrative in terms of a picture showing the overall design, but there would be text associated with this to help clarify exactly what the state diagram, UML diagram, is reflecting. So again, look to that for in your SDD, your software design documents. You will have the UML diagrams, and then you will have text paragraph describing each of the elements of your diagram. Any other comments or questions regarding this diagram? Okay, here's the diagram for the elevator. So the initial state is idle. And I have here, when you reach the idle state, you close the door. We'll see if that is accurate. And then we get an event that says move. And so we enter into the moving state and we say wait for floor and then signal floor reach. So in this state, we are waiting for the floor, and then we signal for the floor reach, which tells me that we're missing something. What was I indicating here? So certainly we went to wait for the floor. Oh, so that's going out to the controller or something else. And then the signal floor reach, I'm having a hard, I guess it's incorporated in the hardware for the elevator that there's a signal to floor reach, but I don't know why you would signal it when you're actually moving. It would probably be some other object, that class or object that I don't have depicted that would be indicating that the elevator has reached its destination, because I wouldn't actually fire off an event when I enter into the moving state that the floor has been reached. That would be rather odd. So any ideas of how you would address that? So we could have an extra action item that there is a feedback sensor or something that we tell the feedback sensor, please signal me when I reach this floor. And when that floor is reached, then an event comes back in that will tell me to stop. So certainly, and actually that might be the controller. That might be the elevator controller. So this signal floor reach may be coming, should not be being produced in the state of moving, but should be received from the elevator controller in the form of the stop. So that's sort of my first cut, but again, it could be an action item to review this and look at this closer. So anyway, we have a stop event that then will take us from moving to stop. And once we are in the stop state, we open the door. And then we have a door delay complete, and that's closing the door, which puts us back in the idle state. So anyone see a problem here? So one thing that strikes me is after the door is open, could you go directly to moving, or do we always go to the idle state, or is there some kind of intermediate state? I'm thinking that from the stop state, we open the door, you can go directly to the moving state if you get a push button that says we're going to move. But that also means that we have to probably have another intermediate state that closes the door, unless the moving state has the closed door operation in it, which would be a viable choice as well. So you can see here as we go through this UML diagram that all kinds of questions come up. And this is precisely one of the big benefits of going through review of a UML diagram, is that it lists questions and says, have you designed this correctly? What are the design assumptions that you have made? Are they correct, or are they incorrect? And those are valuable things to address. Here we have the diagram for the door. It's opened or closed. If you're in the closed state, you need to get the close signal, you stay closed. If you get an open, you go to open. If you're already in the open state, the open attribute takes you back to open, and then we get the close event. Here we have states that go back to themselves. Generally, you want to be inclusive of all possible events that may reflect your actions, and then you could eliminate the redundant ones if the diagram is getting too busy. But initially, at least for the design, the initial design and reviews, you want to be complete and show all the events that are relevant to this class. And then for if the diagram is getting very busy, you can eliminate them and maybe even put a text that you've taken out redundant states that just take, redundant events that just take it back to the current event, to the same event that you're already in. So I think we are, so this one is the diagram for the elevator controller, very similar. We have the various states, the actions that happen inside of those states. And I won't go into this great detail, but same idea. We have events that happen. We have various states that the elevator controller is in: idle, moving the elevator, stopping the elevator stopped, and queuing floor requests as being a state, which is triggered from idle going to the update method going in here. So, and you can see here how these all should correspond to the sequence diagram that I had done earlier. That those same events or same actions are actions that are coming out of the sequence diagram objects. And so out of the elevator controlling, there should be an illuminate button. And so here we have elevator controller sending an illuminate to the button. So anyway, that is sort of a cut at the state diagrams. Any questions about in general about the class before I dismiss you, because we are coming on the end of our time? Any questions about this particular diagram or any of the things that we covered in lecture today?
Do you have a couple minutes after class to take a look at our project?
Sure. Yeah,
Thank you.
absolutely. All right, well, you're free to leave. I'm going to go ahead and turn off the recording. And yes, feel free to stay after.